66 million years ago, a cold wind blew through the desolate gray sky. The world plunged into darkness, with no division between day and night. We were at the moment of a disaster capable of annihilating nearly all life on Earth. A 10-kilometer-wide fireball descended from space, causing these massive dinosaurs to fall. The faint light remaining didn't come from the sun, but from the smoldering fires consuming everything. Yet in this deathly scene, incredible life began to emerge. The tiny creatures, once under the rule of the dinosaurs, were now free. They weren't immediately wiped out, but they would soon face a brutal struggle for survival. Some of them would adapt and evolve to conquer the forests, grasslands, and plains across the world. Others would take flight, dominate the skies, or rule the vast oceans, where the Mosasaurus once reigned. And most remarkable of all, one of these survivors would lead the Earth into an unprecedented era, the era of humanity. Today, that's right. Humanity would not have emerged if the disaster hadn't occurred on that fateful day. It was intense, fierce, and terrifying. But how did those tiny creatures, including our ancestors, manage to survive that catastrophic day? This question leads us to the main topic of today, Human History Series, Episode 1, Surviving the Apocalypse. Before we dive into the main content, would greatly appreciate your support with a like and a subscription to the channel right now. Don't forget to hit the notification bell so you won't miss any of the most exciting videos. Now, let's get ready for today's journey. One more note we'd like to mention to our viewers. This series is not only related to humanity, but also closely tied to the development, separation, and distribution of other species throughout the history of life. Many hypotheses and scientific theories have been proposed, but none have been fully accepted by experts or the public. Therefore, perhaps the theory of evolution, though not yet entirely evolutionary theory, remains the most fitting choice for developing related content in the series. Take a moment to sit down and think. Do you think you could find information about your ancestors from several generations ago? You might easily know about your grandparents through family stories or genealogical records. However, you certainly can't directly know anything about your ancestors from many generations ago, back when feudal societies were flourishing. But what about those more distant ancestors? Research shows that our ancient ancestors, who lived over 30,000 years ago, shared this planet with another species. Not only that, but there were individuals who interbred with them long before. Our ancestors were furry creatures, moving on 4 limbs, always on guard against the lurking predators. And finally, tens of millions of years ago, our ancestors were breathing the same air as the massive, fierce dinosaurs. But who were they? In 2012, while examining an unidentified fossil collection stored in a museum, scientists noticed an anomaly in the statistics about a small fossil that resembled that of a tiny primate species. And incredibly, they discovered and successfully restored part of a fossilized ankle bone of the Purgatorius, a potential candidate for the earliest ancestor of primates, including humans. However, at present, primates encompass a range of mammal species, not only ourselves, but also our close relatives in the great ape family and other genera. Despite many common traits, finding the first primate species is still an extremely difficult task. Early primate species, as well as primitive mammals in general, were relatively small in size. Their bones were poorly preserved in the Earth's fossil record and were almost impossible to find until modern archaeological techniques emerged. It's highly likely that thousands of mammal fossils have been overlooked, even discarded. Unbeknownst to many regarding the fossil of Purgatorius this time, scientists, after many hours of study, concluded that Purgatorius had very flexible ankle bones, a feature commonly seen in tree-dwelling animals similar to modern primates. This isn't the first time scientists have discovered Purgatorius fossils. In 1960, we obtained several teeth. By 1965, when studies on these teeth were published, Purgatorius was identified as the first primate species. However, with just a few teeth, it's hard to imagine what they might have looked like. Take a look here. These small teeth suggest that Purgatorius was likely the size of a mouse. They probably fed primarily on insects and plants. However, whether they lived in trees, as scientists have concluded, is still a big question. Purgatorius is older than any primate species previously discovered, but it wasn't until 2021 that a study revealed the age of Purgatorius. Living between 10 to 140 million years after the extinction event of the dinosaurs, while we have no direct fossil evidence showing that Purgatorius evolved, it is highly likely that they lived during the final stages of the Cretaceous period in a dense forest with massive, ground-dwelling carnivorous dinosaurs. Seeking opportunities to survive in the treetops was a logical approach. Perhaps in some forest on the North American continent, the story of humanity began to be told by Purgatorius. But of course, for that beginning to happen, something had to come to an end. This caterpillar was moving along a high branch, unaware that it was being closely monitored by Purgatorius, waiting for a chance to strike. With most other creatures, the arthropods are nearly invisible due to their color blending with the dark tree branches, but Purgatorius had no difficulty locating its prey with its exceptionally sharp eyes. Meanwhile, a herd of long-necked dinosaurs was crossing the forest with their massive bodies. Wiping out a portion of the vegetation in this area, they now had to continue their aimless journey to find a food source that could meet their enormous needs. The heavy footsteps of the dinosaurs caused the ground to shake, but Purgatorius was not afraid. It knew that the dinosaurs would not harm it as long as it kept out of their path. After securing its prey with a plentiful source of nutrition, Purgatorius allowed itself to rest. It gazed up, intently watching the sky, and that's when this scene unfolded. A strange, blinding light, growing larger by the second, was heading toward the planet. It was beautiful. Lost in its admiration of the beauty, the dinosaurs below were similarly unaware of the danger approaching until it was too late. A 12-kilometer asteroid pierced the atmosphere, blazing like a second sun in the sky. In just a short while, when it reached the surface of the planet, everything would return to dust. The end result we have is the extinction event of the dinosaurs, the end of the Cretaceous period, and the beginning of an entirely new era. The Cretaceous period witnessed an explosion of life on an incredible scale. The biodiversity was facilitated by warm temperatures, abundant oxygen, and favorable climate conditions. Dense forests stretched across nearly every part of the Earth. Not only that, prehistoric creatures were also significantly larger than today's animals. In a study published in 2021 in the Cretaceous Age Journal, the authors stated that they believe long-necked dinosaurs could have been one of the largest creatures ever found on Earth, reaching heights of up to 37.1 meters. But why did they grow so large? The first hypothesis presented by scientists is environmental factors. For example, higher oxygen levels in the air could have contributed to the giant size of dinosaurs. It is believed that during the period just before this era began, the oxygen concentration in the atmosphere increased from 15 to 19% compared to the previous phase, but still significantly lower than the 21% oxygen we have today. Around this same time, the first dinosaurs appeared in tropical regions. Dinosaurs in North America evolved to grow increasingly larger. This helped them easily reach areas with higher oxygen levels in the air while avoiding lower regions with dense CO2. But that's not all. The existence of the Titanosaurus, also known as the long-necked dinosaur, brings us to the second hypothesis regarding why they developed such a massive size. The answer is to have the ability to absorb and access food sources efficiently. Inspired by the giraffe, scientists believe that the long necks of titanosaurs provided them with a significant advantage over other large herbivorous animals. Specifically, they could cover larger areas for food and comfortably enjoy resources that other dinosaurs could not reach. Additionally, they possessed a digestive system capable of processing a massive amount of food in a short period. Scientists believe that titanosaurs had to eat so much that they could not afford to be selective, and their enormous intestines could digest even the toughest plant material. Estimates suggest that it would take 22 hours a day to consume 129 kilograms of various plants. The massive size was an advantage that helped dinosaurs and other prehistoric creatures survive more easily in ancient times. However, this very size became their fatal weakness. After the Cretaceous extinction event, no terrestrial animals weighing more than 25 kilograms survived, and only small creatures lived on to evolve into species we see today. The mass extinction wiped out over 75% of life on Earth at the time. The geological history of Earth has witnessed countless catastrophic collisions, and their scars remain visible to this day. The fried Fornafi crater, 160 kilometers wide, is believed to have been created around 2 billion years ago. According to NASA's Earth Observatory, it has been mostly eroded, but much of it remains. Scientists estimate that the cause of this was an asteroid impact with a diameter ranging from 10 to 15 kilometers. Further still, in the S.H. Barrie area of Ontario, Canada, there is another massive scar similar to Bedford. A 2014 study published in Terra Nova suggested that this may not be. It wasn't an asteroid that caused the impact, but a massive comet or a mix of asteroid fragments and ice that collided with Earth. The cosmic object, about 10 kilometers in diameter, struck the Earth around 1.8 billion years ago. But what we are truly concerned with here is why, despite such a catastrophic impact, small creatures, including Purgatorius, our ancestors, were able to survive. Have you ever wondered about fascinating natural phenomena? This book will help you answer questions about plasmaspheres, auroras, and even how bacteria function within the human digestive system. Published by DK Publishing, a leading publisher of encyclopedic knowledge, the Encyclopedia of Science is the perfect choice for you. The book spans 3 major fields of science: chemistry, biology, and physics. It explains over 100 scientific principles across 7 topics. You could say that every aspect of the world around us can be found in this book. The Encyclopedia of Science has made it to the top 200 bestsellers. The Encyclopedia of Science has made it to the category of encyclopedic books on Amazon, a testament to the book's appeal and exceptional quality. Don't miss the chance to own this amazing book. Order now through the link in the description below the video to receive the best offers. The idea of a mass extinction event during the Cretaceous period was recognized by scientists over 200 years ago. In 1825, French naturalist Georges Cuvier observed significant changes in the fossil biodiversity between the early and late stages of the Cretaceous. Fossils from large animals were gradually replaced by fossils from smaller species, such as birds and mammals. Clearly, something relatively serious had occurred. However, no evidence supported this theory, and all explanations were rejected. The debate continued until a crucial discovery that played a decisive role in the history of the planet. In the late 1970s, geologists Glenn Penfield and Antonio Cago, while conducting aerial surveys in the Mexico, while evaluating oil exploration activities in Mexico, the scientists' mission was to search for viable locations for drilling oil rigs. And it was here that they discovered a massive volcano crater buried beneath the waters of the Gulf of Mexico. The two scientists shared their findings with Petróleos Mexicanos, but the oil company forbade them from disclosing the collected data. The existence of the crater remained secret, known to no one. However, just a few years later, a group of other scientists began reporting unusually high concentrations of iridium in rocks from the late Cretaceous period. They named this phenomenon the KPG boundary. This group was led by father and son, Luis Alvarez, who had won the Nobel Prize, and Walter Alvarez. They surveyed several locations, including Italy, Denmark, and New Zealand, all of which yielded similar results. 66 million years ago, Earth suddenly experienced many anomalies. A very rare chemical element, iridium, appeared in extremely small quantities in the Earth's crust, especially on the surface where it was even rarer. Iridium is very hard but also very brittle, similar to platinum. Moreover, the place with the highest known concentration of iridium is precisely in extraterrestrial meteorites. This led to the hypothesis that the unusually high levels of iridium at the KPG boundary could have originated from an outer space source. The scientists were very excited. In 1980, in a report, they suggested that a large asteroid impact might have caused this phenomenon. This was called the Alvarez-Benfield hypothesis. Benfield even wrote to W. Alvarez after reading the study, but it was puzzling when he never received a reply. It wasn't until 1990 that more accurate rock samples were analyzed, and they finally pinpointed the location of the impact site. The Alvarez hypothesis was reinforced and confirmed as a leading cause of the Cretaceous extinction event. The crater that Penfield had discovered was later named H, after a city near the site. However, our Earth has a diameter of over 12. The Earth, with a diameter of over 12,000 kilometers, is far too large for a small asteroid to cause the extinction of nearly all life forms, including those on the other side of the planet. Therefore, something else must have happened behind the scenes. The crater, with a diameter of about 180 kilometers, allowed scientists to calculate the energy, mass, and size of the object that impacted Earth. The asteroid was moving at a speed 40 times faster than the speed of sound, generating an explosion with a blast equivalent to 100 billion trillion tons of TNT, releasing energy about 7 billion times that of an atomic bomb. It created a massive shockwave, followed by violent tsunamis crashing against the coast of Mexico. Next, a magnitude 10 earthquake shook the ground, accompanied by a rain of rocks and debris falling from the sky. While the direct impact caused severe damage to the surrounding area, it was the aftermath that was the true culprit behind the extinction of the dinosaurs. The impact launched a vast amount of dust and debris into the atmosphere. The mass of earth and rock soared up into the atmosphere, condensing into massive dark clouds. These clouds quickly spread, covering the entire surface of the Earth. Then, they combined with the planet's gravitational pull, causing the dust and clouds to fall back down in the form of enormous rains. Billions of dust particles plunged downward, creating intense friction with the atmosphere, resulting in a sweltering, scorching air. This intense heat set trees and forests ablaze in many places. At this point, the Earth resembled a giant oven, with everything on the planet being scorched. The massive animals were the most tragic victims, enduring fierce gusts of hot winds, each breath feeling like it was burning their flesh. Tsunamis swept over the shores, flattening everything in their path, while earthquakes caused horrifying landslides. Not only that, heat storms wiped out all food sources and caused acid rains, polluting the water supply. After the storms subsided, the Earth was once again engulfed in dust and smoke, with thick layers of dust blocking out the sunlight. The result was the destruction of many plant species, unable to photosynthesize. Yet, our ancestors. We survived, but how? 600 years ago, the last Haast-Ziegel took its final breath, weak and fading, and became extinct. Its prey, the giant flightless moa, had already gone extinct long before. The Haast's eagle didn't perish due to competition or climate change, but because its food source had disappeared. Since the end of the bee era, mammals had gradually dominated the world. However, in New Zealand, this never happened. Before mammals appeared, the only mammals on the islands were a few species of bats. As a result, Haast's eagle became the apex predator, sitting at the top of the food chain. But the arrival of another mammal species changed everything. Humans settled on the islands of New Zealand around the 14th century, and with their advanced weapons and highly effective group hunting tactics, the Haast's eagle stood no chance. Within 200 years, these invaders had hunted most of the large, flightless birds, the eagle's primary food source, into extinction. From the story of Haast's eagle, we can easily recognize an important lesson about the dangers of relying on a single food source. The Haast's eagle didn't just hunt moa. It had a far more complex relationship with this species. In fact, the size of the eagle evolved alongside the moa. Without the moa, the eagle simply couldn't survive. Therefore, while large predators like Haast's eagle, which hunt only one type of prey, may succeed in the short term, animals that are adaptable and capable of exploiting multiple food sources tend to have longer, more sustainable lives. This is especially true when we revisit the extinction event of the Cretaceous period. Purgatorius, whether a carnivore or not, survived in the warmth and favorable conditions at the end of the Cretaceous. While food competition and mating opportunities were never easy compared to the catastrophic asteroid impact, they were nothing. Right after the impact event, our ancestors fell into a dark, cold world where many species once shared a living space that suddenly disappeared overnight. The thriving ecosystem of the Cretaceous period turned into a hell for the surviving animals. However, by exploiting every available resource, not just food, our ancestors adapted in miraculous ways. Any animal that survived the mass extinction event of the Cretaceous period had to develop incredibly smart survival strategies, such as digging burrows, swimming, or making small nests. These strategies allowed them to adjust their behaviors in search of various food sources. For example, they could hunt insects or small animals. More importantly, this adaptability allowed smaller animals, especially Purgatorius, to hide from the worst effects of the impact. Purgatorius, which lived in the trees, had become accustomed to eating insects, but there was still one issue to address. After the impact, the vegetation had been severely damaged, and the large ancient trees or dense tropical forests were no longer present. Our ancestors demonstrated remarkable adaptability in harsh conditions, but evidence suggests that plant diversity could not recover immediately after the catastrophe. Ecosystems took at least 5,000 years to stabilize and return to their original state. To survive these harsh circumstances, Purgatorius had to adapt. Fossils show that the first plants to regenerate after the disaster were ferns, as we see today. However, in the decades following the impact, the world witnessed a remarkable rise in fungi. Since fungi do not rely on photosynthesis for energy, they were unaffected by the severe decrease in sunlight, avoiding the intense competition from plants. A world filled with fungi emerged, creating a completely unfamiliar scene. These fungi provided a crucial food source for animals struggling to survive in the post-apocalyptic world. In the end, even though our ancestors had adapted to life in the trees, they had to be flexible enough in their behavior to risk descending to the ground when necessary. Perhaps Purgatorius altered its behavior to cope with this new reality. Just like modern squirrels, we can observe that they spend most of their time in trees, but occasionally descend to the ground in search of food. Interestingly, our ancestors were able to escape wildfires in the first few weeks following the impact event, seeking refuge underground or in natural stone caves. After living in the trees for many years, they developed the ability to build impressive nests, providing warmth and safety when temperatures dropped. Moreover, the development of swimming abilities, like many modern primates, enabled them to exploit aquatic food sources. There is substantial evidence suggesting that freshwater ecosystems were not significantly affected by the asteroid's impact, in contrast to marine ecosystems or the Earth's surface. Regardless of the survival strategy employed, it is clear that it was successful, and here we are today, in a position unlike any before. While the KPG extinction event may not have been the largest extinction in history, it was a pivotal moment in maintaining the balance of life on Earth. At this point, a hypothesis arises. If the asteroid had not collided with Earth and the Moon, the era of the giant saber-toothed cats might never have ended. Could humans have evolved? To better understand evolution, we must recognize it as a process of development that is not always linear, often undergoing bursts of change during periods like the Cretaceous. Sometimes evolution can explode in the first few million years following a mass extinction event. Mammals evolved into more diverse forms than they had in the previous 160 million years. The sudden disappearance of dinosaurs provided a unique opportunity for mammals to develop with unprecedented variety in size and shape. They capitalized on ecological niches left vacant in a completely reshaped world. A variety of new mammal forms emerged, from ancient rodents like the Primates to the earliest branches of mammals, which evolved into the sea cows and elephants we know today. The Rocky Mountains were forming as wolf-like animals known as Anglo-Lagons prowled the forests of North America. One of them, primates, grew to the size of bears, and thus the entire era passed with mammals becoming larger, firmly establishing their dominance on the new throne. But what about us? 12 million years after the impact, creatures from the new primate branch began to thrive. Their descendants would later dominate the world in the early Eocene. 55 million years ago, the asteroid impact had almost wiped out all life, leaving only remnants of the past. Now, vast volcanic craters hundreds of kilometers wide remain by the Gulf of Mexico, and tropical forests stretched much farther from the equator than they do today. Fossils of tropical plants have been found as far north as Greenland and Alaska. The planet became the perfect place for primates to flourish. They dominated most of the available space, leaping from branch to branch in forests across North America, Africa, Europe, and Asia. These primates shared this tropical paradise with several other animal species. The primates of this period, in general, were small in size. primates were undoubtedly a successful and rapidly diversifying group of mammals. However, it took some time before Earth became home to larger species, such as today's apes and baboons. 34 million years ago, during the following epoch after the Eocene, mammals grew larger and more formidable. But they also faced their greatest challenge, since their ancestors struggled to survive in the post-apocalyptic conditions of the ancient past. The sudden onset of the Ice Age forced all life forms to once again engage in a survival struggle. However, those that survived the end of the world event were able to adapt quickly. The period between 34 million and 23 million years ago marked a transition as the ancient climatic and environmental conditions typical of earlier eras were replaced by conditions similar to those we are familiar with today. In this new world, what stood out most was the gradually increasing intelligence of primates. "17 million years ago, a curious group of primates sat on the ground. Pickin' fruits and seeds fell to the ground, just like the primates of the past. These were tree-dwelling creatures, but their ability to move on all fours allowed them to easily navigate the ground. They were much larger than Purgatorius, their ancestors, and a few special individuals in this genus could grow to the size of a female gorilla. Upon detecting approaching predators, one member of the group would emit a warning call, prompting those on the ground to quickly return to the safety of the trees. Clearly, compared to their ancestors in earlier eras, these primates were not only smarter, but also had larger brains than other similarly sized animals. It was likely around this time that primates began to show a trend toward developing superior brain capacity. All of this set the stage for our eventual emergence. 10 million years later, the world witnessed the rise of ancient lemurs and the river giants, iconic species of the era. However, for many other reasons, this period must have been the era of the monkey family. They had evolved with bodies and brains that enabled many species among them were able to cope with a variety of challenges, from environmental issues to more complex ecological problems. And then, a completely different species of ape appeared. In just a short 7 million years, an eye blink in Earth's history, its descendants would go on to build cities, create art, develop language, and establish complex belief systems. They would be found everywhere across the globe, building skyscrapers, creating supercomputers, and eventually conquering the skies. It's all truly astonishing. However, none of this would have happened without that fateful day, the day the Cretaceous ended, and our tiny ancestors miraculously survived. The asteroid that struck Earth wiped out much of life, but for humanity, it was only the beginning. Fate seemed to have already been written. The throne changed hands the moment the dinosaurs fell. Yet to reach where we are today, humanity had to overcome countless challenges over tens of millions of years. But have you ever wondered, are we really that different today? Have we truly become a superior species compared to other primates? As unbelievable as it may sound, I must say that in reality, humans are still, in part, apes. We will continue this strange topic in the next episode of this series. For now, goodbye, and see you in the next videos. I wish everyone a wonderful day with their family.